So now we can find the optimal Q1. Now, so if d pi OD Q1, so we sorted the equation first until very soft and now. So d pi OD Q1 equation set it. So very simple. You can see you have to do your differentiation here. With respect to Q1. You only end up with this one equation, one unknown. Solving for Q1, you have for Q1 equal. Okay, that's very simple. We found Q1 equals 30, now we put into equation 1, we get Q2. So when Q1 is equal to 30, Q2 is how much? 15. Okay. Any question? Now how to find the price? The price is 70 minus Q1 plus Q2. Q1 is 15, Q2 is 30, so 70 minus 45. So you get the price. Okay, so we're done with the how to find the honor now? So how to find the honor solution? Honor, you will start with term 1 or term 2. Honor, you will start with term 1 or term 2. Doesn't matter. Right. So anyhow start. Here say control. So profit is total revenue minus total cost. And as usual, P is this. Okay. So average cost given as how much? Average cost is how we found it. Okay. So that's it. Average cost times 1C. So that's the total cost. Now, how much to produce for firm 1? So we d pi OD Q1. So we d pi OD Q1 set to 0 here. Now, therefore, we rearrange the equation. 2Q1 plus Q2 is equal to this. Now, can we find Q1 and Q2 from this? Can. But you only have one equation. Now, can we use one equation to solve for 2 unknowns? Can we use one equation to solve for 2 unknowns? Is that possible? But in this case, it's possible. Because we can apply symmetry. So we need to use 2 equations. Now why we can apply symmetry? Because or not. Honor is a symmetric model. So because it's a symmetric model, so this is one of the reasons we can apply symmetry. Alright, that means what? If you apply symmetry, that means these are the same. Okay. So therefore, we don't need 2 equations. These are the same. Okay. Now, how we know they are the same? Because if they are the same, I can write this as what? If they are the same, I can rewrite this as what? Q1. I can rewrite this as Q1. Q1. Q1 is equal to 60. Q1 equal to 80. And because they're the same, we found one, we found one. Right? So the only question now is, how we know that the same? We know because if we look at firm 1, what's the average cost for firm 1? How much is the average cost? Okay, so the average cost is this. For firm 2, the average cost is this. So these two curves are their profit function the same? Are they differential? So are they identical? That's right. Now if these two are identical, exactly the same equation, they are exactly identical. Now that's the case then you d pi 1 over dt1 and equal to 0, and you d pi 2 over dt2 and set to 0. When you solve, will the quantity be the same? When you solve, will the quantity be the same? So when you solve this through, if their equations are exactly identical, right? When you differentiate, you solve for their quantity, and their quantity be the same. Or must they be different? Must be the same, right? Cannot be different. That's why you can use symmetry. Because they are identical, so therefore it has to be the same. Is it? Since they are identical. Okay, any question? So that's all. If you don't understand this, you understand this? If every firm, the equation is this. What do you get? Every firm, the equation is this. But the x be different. Every firm, the equation is this. But can the x be different? Possible, right? If your equation is identical, how can the x be different? Now, this you understand. Okay, if this you understand, then there's no reason why this you don't understand. The equation are exactly identical. firm 1, firm 1, firm 2, firm 2, firm 2. Right, take away all the names. Are they the same? Is that clear? So because the equations are identical, so we can apply it. Okay. So our job becomes very simple. Finish. One equation, enough to solve all the arguments. Alright, we need two. So, found one, we found one. So what's the price? Price is 17 minus 20 minus 50. So the profit was the same. The symmetry, we found one, we found all. And why? Because if every firm, the price is the same. If every firm, the price is the same. Their cost is the same. And they produce the same quantity. And their profit is different. Possible. Right. You understand? Everyone sells the same price. Everyone sells the same quantity. Everyone has the same cost. How can their profit be different? Okay, so very simple. Solve. You found one, you found all. Any question? Okay. Now the other thing is this. The good thing about symmetry is that it's a very powerful instrument for you to solve anything. It means if I were to change this to n firms, n firms, what's the equivalent? I don't look at the word police, I look at n firms. If there are 1 million firms in this market, what's the amount equivalent? 1 million firms. How to find the equivalent? Here n can stand for 1. If there are n firms, so we solve the profit function for firm 1. So d pi only Q1. If there are n firms, then here will be Q3, Q4, Q5, Qn. Agree? So what's the CC can do it compound. So Q3, Q4, Q5, Qn. Okay, that means if there are n firms, and here you do minus Q3, minus Q4, minus Q5, all the way to Q1. Qn, right? You see it? If there are n firms, the price is how much? Define as what? There are n firms, right? Because if there are n firms, you understand? The P is given as 1. If there are n terms, this Q is how much? Q1 to Qn. Q1 to Qn. So 70 minus Q1 minus Q2 minus Q3 minus Q4 minus Qn. Okay? Because the big Q is Q1 to Qn. No longer Q1 and Q2, right? So this is for P times Q1 minus 10 times Q1. So for firm 1, how much we produce? Okay, so the n terms, they go to program quantity for every term. That's right. Found one is found one. Because we can apply symmetry, right? They are the same parameter. So if you apply symmetry, then you don't need that many equations to solve parameter. You can rewrite all these as Q1, 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 Q1. So you solve for Q1, that's it. You found one, you found one. Okay? So therefore, the n is the number of terms. If there are two terms, Q1 will become how much? 20. 3 terms, how much? 15. If there are 1 million terms, 60 over 1 million and 1. Okay? That's fine. So the good thing about symmetry is this. You can use one equation to solve 1 million numbers. Okay? But I think the only problem is, can you identify symmetry and look at the assignment and look at the test? You cannot. So that's the only problem. You solve two equations, but you cannot see that they're similar. Then sometimes some equations are not similar, you see where they come out. That's the only problem. Okay, so I think if you cannot see, then what you do is this. If you cannot see, always remember, if it's a symmetric model, which way you check for this? If this condition holds, you apply to this. Okay? Then this time the beginning of class. Now we will try to use page 3. Page 3. So first we check whether the model is a symmetric model. If it is, you can apply this square. One more thing, check for this. Very important. Check for this. So that means you can apply this to which model? The last three models. Which one is the last three models? From page 3. This one is copy this here, right? Page 3. Okay, any question? That means you can only apply this to 3 models. Which one? Which 3? What type of model are they? Symmetric. Simple. The next thing, have to make sure that costs are the same. Otherwise, cannot use. Okay? Any questions? Well, it's very simple. If the costs are not the same, you cannot use. You look at this. When I saw for you come out at the beginning of class, this come out. You notice there at price symmetry? I did not write why. Why? If the average costs are different, can I use symmetry? I did not. The equations are not identical. You understand or not? How can I apply when the equations are not identical? In other words, I said before, this is tan, but this is this. Can we apply? Impossible. They are not identical. Or not? How can you apply? So this one, if you cannot tell whether it's symmetrical or not, you just memorize this. First, it must be a symmetric model. Second, check to ensure that the costs are the same. If the costs are not the same, that means you cannot apply. Alright? Okay? Any questions? So let's go for the previous grade. Now, the assignment 2, those of you who have hand out.